about all the rules that go along with the crossover method. So the first thing we want to ask is, what is a superscript? Well, a superscript defines a charge of an atom. It's at the upper right-hand side of your element. This particular element is a magnesium, and it has a positive 2 charge. So what is a subscript? Well, a subscript defines how many of the atom are actually present. So if you see right down at the bottom, it's a magnesium chloride. There are 2 chlorides present in that compound. So you want to make sure you know the difference between a superscript and a subscript. Okay, so when do we actually use this particular method? Well, when we have 2 monoatomic ions that have different charges. If you see here, you have a magnesium that has a positive 2 charge, and then the chloride that has a negative 1 charge. The superscript and the subscript will cross over. So back to the same problem we've been looking at, okay, we have a magnesium, which is positive 2, and that is going to cross down to the right, okay? Then we're going to have your chloride that's a negative 1 cross down to the left. So what that means is our magnesium is a positive 2 charge. So when we cross down, that chloride gains that 2. And now we're calling it 2 chlorides that are within that compound. And because there's a 1 in front of that negative sign, that magnesium is considered to be a 1. Now I want you to notice that charges are not crossing. Only the superscripts are crossing. The charges don't cross, okay? Let's just go through some examples. For example number 1, we have a sodium ion, which is a Na+, and then a sulfide ion, which is a negative 2. 2 different charges, right? So this is actually what we're going to be looking for. And the way that this happens is we took our sodium charge and we put it on our sulfur, okay? Sulfur has a 1. Now, because that's understood, we're not going to have to show the 1, but we'll get there, okay? And then that negative 2 on the sulfide is going to transfer down to sodium. So your negative 2 transferred down to sodium. Again, notice that the charges are not crossing. Only the numbers cross. And because, again, like I said, we're understanding that there's a 1 in front of that positive on the sodium, we do not have to showcase that in our final answer, which is Na2S. All right, so we're just going to do another example. So we have, for our next example, we have a barium, a Ba2 positive, and a nitrogen 3 negative. So again, that's a charge. That 2 plus is a charge, and then the negative 3 or the 3 negative is also a charge. And those are going to cross down to each other just the same as we did the first one. And that's how we got the Ba3N2. Our charges do not cross. Only the numbers cross, right? So only the numbers. There are no charges crossing. And our final answer is going to be a Ba3N2. All right, so another example. We have a Ti4 positive and an O2 negative. Those are our charges. And we know that we're going to cross them over, and they're going to change elements because we're using the crossover method. So our numbers cross over, but not our charges. We come up with an answer of Ti2O4. This particular problem is we have a Ti2O4 in the answer, but we're not done. Okay, Ti2O4 can be simplified. And if we simplify these numbers, we have a Ti2 and an O4. If we simplify those, we have a TiO2, and that is actually our final answer. If 2 ions have different charges and at least 1 polyatomic ion is involved, what are we going to do? So if there's more than 1 polyatomic ion, we're going to use parentheses to make sure to simplify the subscripts. So I'm going to show you a couple examples of those. The first one, I have NH4 plus SO4 2 negative. The NH4 plus is a polyatomic ion, but so is the SO4 2 negative. They are both polyatomic ions. We have a 1 positive and a 2 negative charge on these. So what happens is I'm going to go ahead and cross them over. And we know that there's only 1 on that NH4. But if you look right here, we have an SO4 negative 2. So now there are 2 of the NH4s. And basically our final answer is going to be NH4 with parentheses, because it's showing that there are actually 2 of those ammonium ions, okay? That polyatomic ion is called an ammonium polyatomic ion, or just an ammonium ion. There are 2 of those. So you have to use those parentheses to represent that. And then you have the SO4. This is not something that you're going to simplify, because basically we're not saying that there are 2 SO4s. If we were saying that there were 2 SO4s, we'd have parentheses around that SO4 with a 2 subscript, just like we do with the NH4 2. But this is actually going to be our final answer. Now, polyatomic ions can get a little confusing, so I want to do a couple of more examples for you. Here I have a calcium 2 positive and an NO3 negative. Now that NO3 negative is a polyatomic ion. Our calcium has a positive 2 charge, and our NO3 negative has a 1 negative charge. And so we're going to cross those over just like we have been the whole time. And that negative 1 is understood to be a 1 on that calcium, and now we have 2 of those NO3s. So our final answer is going to be CaNO3 2. And again, we have to use parentheses because there are now 2 of those NO3s. All right, we got one more example to get us there. We're going to finish up with this one example. So what we have here is we have a lead. Lead is a 4 charge, it's showing, and a charge of positive 4. And then we have a CO3 negative 2. Now that CO3 negative 2 is a polyatomic ion. If you don't know how to differentiate between a monoatomic ion and a polyatomic ion, you have a polyatomic ion sheet available to you. You can find it in a D2L, you can find it online, you can snap a picture in the naming monoatomic and polyatomic ion video in your video library. So our lead has a positive 4 charge, our CO3 has a negative 2 charge. So we're going to cross those over just like we have been the whole time. And now we have Pb2 and we have CO3 4, right? So Pb2, CO3 4. Now this one, this can be simplified. We don't want to forget to simplify it because it is incorrect if it's not simplified. So our final answer is going to be Pb, CO3 2. And again, we are using those parentheses because we're showing that there are 2 of those CO3s. I hope that this video has helped you a little in being able to understand what we're doing with our crossover method. If you have questions, you should direct those to your instructor or the tutorial center. And I hope this video has helped you.